When we look at the vast tapestry of life on our planet, from the smallest insect to the largest whale, we see an incredible diversity of forms. Yet within this diversity, there are unifying patterns, grand blueprints that connect seemingly disparate creatures. One of the most successful of these blueprints belongs to a group we call the Chordates. At its simplest, a chordate is an animal that, at some point in its life, possesses a special rod-like structure for support. This group is wonderfully varied, encompassing everything from the humble sea squirt, which looks more like a leathery bag, to the magnificent blue whale, the largest animal ever to have lived on Earth. It is a story of adaptation and evolution that has unfolded over millions of years. The true genius of the chordate design lies in a few key features that all members share, at least during their early development. The most fundamental of these is the notochord, a flexible rod made of cartilage-like material that runs along the back of the animal. This provides a central axis for muscles to attach to, allowing for powerful, coordinated movement. Above this notochord lies a hollow nerve cord, which in many chordates develops into the complex brain and spinal cord. All chordates also have pharyngeal slits, which are openings in the throat. In fish, these become gills for breathing, while in land animals like ourselves, they are only present in the embryonic stage, later developing into parts of the ear and jaw. Finally, every chordate possesses a post-anal tail. This is simply an extension of the body that continues past the end of the digestive tract. For many, this tail is a crucial tool for propulsion, helping a fish to swim or a monkey to balance as it leaps through the trees. Even in humans, where the external tail has been lost, its remnant exists in our skeleton as the coccyx, a small bone at the base of our spine. These four features, the notochord, the dorsal hollow nerve cord, the pharyngeal slits, and the postanal tail, form the fundamental body plan that has allowed chordates to conquer every corner of our world, from the deepest oceans to the highest mountains. It is quite remarkable to think that you, I, and every bird, snake, and frog share this ancient heritage. While some chordates, like the tunicates, are simple filter feeders that lose many of these features as they mature, the vast majority belong to a more familiar group, the vertebrates. In these animals, the flexible notochord is replaced by a much stronger, more complex structure made of bone or cartilage, the vertebral column, or backbone. This innovation provided a sturdier frame, protecting the delicate spinal cord and allowing for greater size and more powerful locomotion. It was this development that truly set the stage for the explosive diversification of the chordates we see today. The first and most numerous of the vertebrates are the fishes. They are the pioneers of the chordate world, having evolved in the ancient seas over 500 million years ago. Their entire existence is a testament to life in water. With gills derived from their pharyngeal slits, they expertly extract oxygen from their aquatic home. Fins, supported by bony or cartilaginous rays, provide stability and steering, while the powerful muscles attached to their backbone propel them through the water with grace and speed. From the shimmering shoals of sardines in the open ocean to the bizarre camouflaged stonefish lurking on the seabed, fishes have adapted to an astonishing array of underwater niches. Next in the grand procession of life came the amphibians. These are creatures of two worlds, their name literally meaning double life. They represent a pivotal moment in evolution, the move from water onto land. Amphibians like frogs, salamanders, and newts typically begin their lives as aquatic larvae, breathing through gills, just like their fish ancestors. As they mature, a miraculous transformation occurs. They develop lungs for breathing air and grow limbs for walking on land. However, they are never truly free from the water. Their skin must remain moist to aid in respiration, and they must almost always return to ponds or streams to lay their soft, jelly-like eggs. From the amphibians, a new group arose, one that broke the final tie to the water: the reptiles. The key to their success was the development of the amniotic egg. This remarkable innovation provided a private little pond for the developing embryo, complete with a protective, leathery shell that prevented it from drying out. This allowed reptiles, such as lizards, snakes, turtles, and crocodiles, to venture deep into dry, terrestrial environments. They also evolved tough, scaly skin that reduced water loss and more efficient lungs for breathing air. This allowed them to become the dominant land vertebrates for millions of years, a reign that included the awe-inspiring dinosaurs. Reptiles gave rise to two other immensely successful groups of chordates. One of these took to the skies: the birds. Birds are essentially modern-day dinosaurs, having evolved from a group of feathered theropods. Their bodies are masterpieces of engineering for flight. Their forelimbs have been transformed into wings, covered in feathers that provide both lift and insulation. To save weight, their bones are hollow but strong, and they possess incredibly efficient respiratory systems to meet the high-energy demands of flight. From the tiny, hovering hummingbird to the majestic eagle soaring on thermal currents, birds have claimed the air as their own, demonstrating the incredible adaptability of the chordate body plan. Following the great age of reptiles, another group of chordates rose to prominence: the mammals. We are, of course, mammals ourselves. What sets us apart is the presence of hair or fur, which provides insulation, and the ability of females to produce milk from mammary glands to nourish their young. This parental care gives mammalian offspring a significant head start in life. Mammals are also warm-blooded, or endothermic, meaning they can maintain a constant internal body temperature. This allows them to be active in a wide range of climates, from the freezing polar regions, home to the polar bear, to the hottest deserts, where the camel thrives. The diversity within the mammals is simply staggering. Some, like the bats, have evolved true powered flight, their wings formed from skin stretched between elongated finger bones. Others, like dolphins and whales, have returned to the water, their bodies becoming streamlined, and their limbs evolving into flippers, echoing the forms of their distant fish relatives. On land, mammals range from the tiny bumblebee bat, which weighs less than a penny, to the mighty African elephant. This group includes swift runners like the cheetah, powerful diggers like the mole, and intelligent primates like the chimpanzee, which are our closest living relatives in the entire animal kingdom. Let us not forget the birds, a class of chordates that numbers over 10,000 species. While flight is their most famous attribute, many have adapted to life without it. The ostrich of the African savanna, the largest bird on Earth, uses its powerful legs to run at incredible speeds to escape predators. Penguins, found in the frigid waters of the southern hemisphere, have transformed their wings into powerful flippers, effectively flying through the water in pursuit of fish and krill. Birds also exhibit some of the most complex behaviors in the animal world, from intricate courtship dances to the construction of elaborate nests and epic, continent-spanning migrations. It is a fascinating fact that the smallest chordate known is a tiny fish called Phytocyprus progenetica, found in the peat swamps of Southeast Asia, which measures less than 8 millimeters long. At the other end of the scale, the blue whale can reach lengths of over 30 meters and weigh nearly 200 tons. This incredible range in size, from something smaller than a fingernail to an animal longer than 3 buses, is a powerful illustration of the versatility of the chordate blueprint. It has proven to be a foundation upon which evolution has built an almost endless variety of forms, each perfectly suited to its own way of life. The global spread of chordates is a story of total conquest. There is virtually no habitat on Earth where they cannot be found. In the vast oceans, which cover over 70% of our planet's surface, chordates thrive at every depth. Fishes, whales, and sea turtles patrol the sunlit surface waters, while strange and wonderful fish species have adapted to the crushing pressures and eternal darkness of the abyssal zone, miles below. From the vibrant coral reefs teeming with colorful fish to the icy polar seas where seals and penguins hunt, the waters of the world are a chordate dominion. On land, the story is just as impressive. Chordates roam every continent, from the frozen tundra of the Arctic, where muskoxen and caribou survive the extreme cold, to the scorching sands of the Sahara, home to reptiles and mammals adapted to conserve every drop of water. They inhabit the dense rainforests of the Amazon, where monkeys, jaguars, and an incredible diversity of birds and frogs fill every level of the canopy. Even the highest peaks of the Himalayas are not beyond their reach, where sure-footed mountain goats and high-flying birds like the bar-headed goose make their home. Chordates have proven to be masters of terrestrial life. And then there is the air. While insects were the first to conquer the skies, chordates followed with spectacular success. Birds have colonized the airspace above every continent and ocean, undertaking remarkable migratory journeys that span the globe. Bats, the only flying mammals, dominate the night sky, using echolocation to navigate and hunt for insects. Even some reptiles like the gliding lizards of Southeast Asia have found ways to travel through the air, launching themselves from tree to tree. The sky is not a barrier, but another realm that chordates have made their own, a highway connecting different parts of their world. From the familiar sight of a sparrow in a city park to the elusive snow leopard in the mountains of Central Asia, chordates are an integral part of our planet's biosphere. They are hunters and prey, grazers and browsers, pollinators and seed dispersers. Their interactions shape the ecosystems they inhabit. The sheer breadth of their distribution and the variety of their forms are a powerful testament to an evolutionary design that emerged hundreds of millions of years ago. They are everywhere, woven into the fabric of life on Earth, a constant and vital presence on the land, in the water, and in the air.